Hi everyone, it's Nono here, and today I want to welcome you one more week to the Nono.MA livestream. This is a space that I reserve every Thursday where we take a look at topics that have to do with creative coding, machine intelligence, art and design, and many other things. Over the past weeks, we've been taking a look at machine learning and also workflow automation and how to do things more efficiently. And in more specific terms, we'll see what we've done last week, so last Thursday, because we managed to take a look at what Tensorflow Js is and created a model. And this was a pix-to-pix model from one of the pre-existing trained models that I had. If this is the first time that you join the live stream, this is Nono Martinez Alonso. This is my YouTube channel, so you might be watching this live or maybe watching the recording afterwards. They all stay on YouTube. And, this is week 29, so we've been going for a fair amount of time now. And I hope that you are enjoying it. I will, appreciate a lot your comments, your suggestions, your questions. And without further ado, let's get started with today's live stream. I will be really thankful for whoever gets to connect today with us. If you can tell me if you can hear me okay, if you can see me okay, and how everything's going. I will ask you to like this video to support the work that I'm doing here with the live stream and the videos that I'm putting up. And in case that you're interested on being notified when I go live next or when I upload new videos, click on subscribe and make sure to activate the notifications by clicking on that bell. You can also join us on the Discord community. So you have an invite at nono.ma/discord, and this will allow you to join the community where many others are already participating and sharing their projects and discussing things that have to do with machine learning and sketching, podcasting, and other creative endeavors. Last week, as I mentioned, we managed to see some stuff of Tensorflow JS. We didn't get to AA drawing or Next.js. And today we're going to continue with the Tensorflow JS and pix-to-pix part. And, if you want to submit a question to the Getting Simple podcast related to the topics that we cover on the podcast, go to gettingsimple.com/ask and click the appropriate button. Today, we're going to cover things, not this one, so Tensorflow JS, pix-to-pix, and AI drawing, maybe not Next.js. This is old. And this is what we're going to cover now. All right, so let's maybe use this slide. Hi everyone, it's Nono here, and we're now going to take a look at Tensorflow JS and how to use a pix-to-pix model in our web app, in Node.js, or in an application that uses JavaScript. All right, so without further ado, I think we can get started with coding. Again, this is Nono Martinez Alonso, and we're going to get to do some machine learning and creative coding today. If you're joining the live stream, I will really appreciate if you leave a comment on the chat. You tell us where you're connecting from, who you are, and how you found us. Or if you have been watching for the past weeks, just let me know if you can hear me okay. Let me know you're here. And that's it. All right, so I'm going to go and open my notes. So I'm going to open here a file that I have with my notes. So for this, I use Notion. So I'm going to make sure that I open the right document. So the live stream document, which we have up here now. And we're going to go to the bottom. So here we're making an effort to be consistent with the formatting. And one thing that we have is the to edit list. We're editing all videos from live streams to upload as separate tutorials. So let me open the channel just one really quick second to make sure that you can see what I'm referring to. All right, so we go to my YouTube channel. What we have now is, we have new episodes. So this is a new episode with Luis Ruiz. So this is a section of announcements, daily announcements. So we have this new interview with Luis Ruiz Padron on sketching, writing, and teaching through the lens of architecture. So this is a full-length interview that you can enjoy wherever you get your podcasts. So this interview is 1 hour and 20 minutes, and it features many different topics. You can go to the episode notes to see the outline, the chapters, and many of the things that we talk about in detail. All right, so I'll leave you with that. So this is was released on Monday, and this will be the first ever interview to be released also as video. So Daniel Natoli has helped me record this and produce a piece that's going to be the first ever episode in be released with 2 cameras, and you're going to be seeing us. We are wearing face masks, which it's really problematic of the pandemic, but what can we do? All right, and what I was gonna show, so we have this new set of playlists now. So we're gonna have one that is about web stuff. So we have here, not this video. YouTube really slows down my computer while I'm live streaming. This really quickly, if we can. All right, so this just reminded me that I'm not piping audio properly to OBS, but what I wanted to show you is, I cannot. Well, there is this new playlist that has so far these videos, and these were extracted from previous live streams, and we'll be uploading more. So I have a tutorial that will be released next week on how to draw shapes with OpenCV programmatically in Python. All right, so let me actually make a test quickly. Well, we might not need to pipe the audio today, so I'm gonna leave it as it is. All right, so today and again, let me know if you can see me okay, if you can hear me okay, and everything's going well. And the topics for today, we're going to try to make pix-to-pix predictions with Tensorflow Js on our browser. We have some code here already, and what we need to do is serialize our input images somehow and actually request predictions. All right, so we have here, so this is from live 28, so you can go to it here. So let me see if I can bring this URL so you can see. So it's github.com Nono.MA live, right? And then you just have to navigate to directory 0028 for live 28, and then is a tf.js predict pix-to-pix. And as always, I'll paste this on the chat. So this is links for live 29. Pix-to-pix, live 28, prediction code, Tensorflow JS. Right, yeah, and I might be able to just bring this here. Huh. Nice. These are the new auto-generated previews of GitHub repositories. This is pretty cool. This is being a feature that has been asked for forever. All right, and you can set your own as well. All right, so for those of you who are joining, we started a bit earlier today than usual because I'm always after time. So I wanted to make sure that we started on time today. Okay, so we have this here and we are going to use that. So I'm gonna create a new directory. So this is gonna be on the live repo, and I'm gonna copy directory 28. Let me just make this bigger so you can see everything I do as I do it. All right, so what I did here, so we go step by step, right? I have a folder, and we can maybe minimize Notion. So I have a folder, and I can, you can look at it. It's my repo for the live stream, and I can do ls to list the directory. So we see all the contents, right? So if I open that directory, you can see that these are the contents of the directory. The things are listed here. And if I want to take a look at the README, for example, I could do cat README, or with a nicer tool, I can do glow README. This is something you have to install on your computer, and then you get the markdown file rendered on the terminal, right? So I started creating these nodes here. We stopped doing that because it took a bit more time to maintain. So right now we just have the folders. So we're gonna copy recursively folder 28 into folder 29 and see if that works. All right, so now we have folder 29. So we can go here, we list, and then we have these two things. We don't care about the bus download images, and we have this TF predict pix to pix. Maybe we can call it V2 or V29. V2 is okay, I guess. All right, so now we enter that folder and we edit it. So when we open this folder, we're gonna see exactly the same, but I'm going to build up. So we have like a folder for live 28 in case you follow that video, and a folder for live 29 in case you follow this video. And right now here, what we're doing is we're the core part of this example. So if we go to our settings, maybe let's make this 16 or maybe even 18. Right, so if we look at this code here, I have I was serving a model. So let's try to understand this code, right? So topics for today were announcements, pix to pix, prediction recap, and then we're gonna try to do pix to pix, load input image to vector, predict, output, right? So prediction recap. So we have here a code that is loading Node.js. So if I go here, Node.js is not there. So the first thing I'm going to do is, well, go to package.json. I don't know if I can do this. Yeah, no. All right, so we have these two dependencies. There is no node models directory in this folder. So we open, we don't have it. And the only thing that we have to do here is npm install or npm I, right? It's the same command. And when I do this, the node models folder gets created and many packages inside of it. You can see TensorFlow is being downloaded and more packages are being downloaded here, and that's being resolved there. So when we finish, we end up with, I don't know, this is a big folder. And let's see. Okay, so this is taking some time and then it resolves. So added 125 packages, added 126, blah, blah, blah. All right, 600 megabytes, right? So we have all of our packages here. And I guess here we have TFS node, which is a, so this is the TFS node. We take a look here, is the TensorFlow node backend, right? So this uses your computer resources in a more efficient way than TensorFlow JavaScript and connects to the computer, and it makes it run in C++, so it runs more efficiently. All right, so if we load that version, you know, this can only be used in Node.js. That is what we're going to run now, not in plain JavaScript. So for that, you will have to do this. If we run the algorithm like this, we'll get a warning saying, oh, if you're a node, you can use TensorFlow JS node to run more efficiently, right? So the first thing is we've imported our packages here. So we import everything from this package as TF. And we say, okay, we loaded TensorFlow JS, and then we let our model be a tf.layers model. This is a definition in TypeScript of the model. So we define model variable, log, well, we don't really need that many. So inside of this async block, right? So in case you're not familiar with TypeScript, if you do something that is asynchronous, you need to run it inside of an asynchronous block, right? And this function is asynchronous. If you write await, then that makes it run synchronously, right? So we're waiting for, in this async block, we're waiting for this asynchronous execution synchronously to execute. Let's see if we can take a look at how that works. So let me see if I can create a new right, so async await example. So maybe we can record a quick tutorial on this, right? So this is our function, then alert. All right. Yeah, so that's the pattern of promise. Async await, but we're not going to spend a lot of time there right now. All right, so in this example, what we did is that inside of this async block, we are loading. So let me come here. Cool. So we're loading the model that we have to serve via HTTP. So we have to load this model from a web server, and we have to host or run a web server locally to be able to load the model, because this function doesn't let you, I think for security reasons, it doesn't let you load a model from your machine, but only from a web server, from a local server. All right, so let me see if I can. All right, so okay, so this code already loaded the model, it predicted, and what we did is that we were creating a fake input tensor. So this is a random uniform, so this creates a random tensor. So it's like a tensor with a batch of 1, which is the exact shape that we need to input pix to pix. We could have as many images here as we want. So this would be 4 images of 256 by 256 with RGB channels, right? This is just 2 or 1, or we can have 100, and we'll get back a tensor with the same shape. And once we define that tensor, that right now is, create a fake batch of tensors with the desired input shape, or maybe the required input shape, and we're going to generate that, and then we predict with the model. So we say await model predict input tensor. This is an asynchronous function, and if we write here await, this line is gonna wait to move below until this is executed. Otherwise, we'll get here and this model won't be resolved yet, right? We could use the promise pattern to make sure that we first do this, and then we have the, like when we predict and then we do the then. So we could say predict input, then, and then do something else, and then, right? So we have the promise pattern, but that will be something that we might want to put into our to-do list, right? So this we already did. We probably need a tutorial for that. So we can say, okay, in live 28, export a pix-to-pix model to Tensorflow JS. That's good. And and here, and this is something that we'll remove when we edit the video, this part here where I'm writing things. And where am I going? All right, so we have here possibility. Okay, cool. So that's that. And what we're gonna do now, so is see that after we predict, we have our prediction, so we can log the prediction and we can make other predictions. In this case, we will just want to do one prediction and then save the prediction as an image. So our challenge, right? Our challenge today is to get, let's go down. Our challenge today is read an image, and then maybe let's make this bigger. Read an image from disk. Convert the image to TF tensor as this. Then we'll feed the image to the model.predict function, and then save the image to disk. Right, so this is what we're going to try to do. It's fairly simple, fairly contained. I think we can get it. And this is with fs. We already have this function somewhere. All right, so the first thing that we're going to do is, as we said, reproduce what we did last week. So we're going to make sure we know where the model is, which is probably in here, and pix2pix model. So we have the model is in here, pix2pix model Tensorflow JS, and we're going to simply run HTTP server. All right, so the model should be exactly in the same folder, except that we don't have this right now. So if we go to this URL, we're gonna get locally the information for our model. All right, yes, and this is loading the JSON file from here, right? So we have here a JSON file, you can see, and if I were to do cat model.json, we get exactly that same thing. So we're literally serving our model as a website, right? The folder of our model as a website. We can, I think, do file listing, right? So we see everything, and we just care about this one. All right, so we'll leave this here, empty tab, and we'll leave this server. Maybe we can run this here, so we can run everything on Visual Studio Code. So I could do PAD. We open a new one. So look at this. I'm clicking here to open a new tab. So we have two different tabs of the terminal here. So I go to my desired directory and I do HTTPS server. And that means that I can close my terminal and that we can continue to see the model. All right, so this model is there. So up to here, we can get this running and everything else should work as well, right? So what we're gonna do, we're gonna go to our terminal one. So I'm gonna click here and go to the CSH, and then down here, I'm gonna run, this is, a note here, this is TypeScript. So TypeScript needs to be transcribed into JavaScript to run. So below here, I'm going to do this. I'm gonna, if I do node index.ts, this is gonna fail because this is not valid JavaScript. But we can do ts node, right? So we do ts node. We have a repo that runs in TypeScript, and I don't know if this works. Yeah, right. So this is TypeScript, and what we can do instead is use ts node index.ts to run this, right? So when we do this, so let me see if I can maybe make this bigger like this. So I run it, and what happens here is, let's see if it works. Yep, so we load TensorFlow, so loaded TensorFlow, we're loading the TensorFlow model. So this takes some time because it's a big model, and then we're predicting. So we predict and print the first output, and this is, it's a huge array, has 256 and RGBs. And if we wanted to, for instance, get the first 3 colors, I guess we could, instead of just printing the entire thing, we could grab part of it. So we could grab, let's say 0, 0, 0. Let's try that. TS node index. Let's see what happens. So I'm trying to get the RGB values, maybe. I don't know if we're gonna. I expect to get the RGB values. Otherwise, no, maybe we're getting the first row of the first image. Okay, so those are nans. Great. That's not great. And then we're gonna get another 0. All right, so the one thing that I don't like is that we're getting nans, because I thought the other day, we were actually getting proper values, and these might mean that we're actually getting like an output that is invalid. All right, so we get, these are our RGB values, which are not valid. You can tell that. Array sync. What is the other function? So we're gonna go into our live here. So let's see. So announcements. All right. So we'll take a look at this later. This yeah, this probably doesn't, yeah, I probably have to restrict that access there. All right. So let's take a look quickly. TensorFlow JS. Let's take a look at the documentation here. All right, where is the API? TensorFlow JS. And we're taking a look at sync. So array sync and buffer sync and data sync. So let's see if we can run instead. What's the difference with data sync? Okay. I'm not sure if we can do maybe print. Let's see what happens here. Okay. So this is our tensor, which shouldn't really be like this. Random uniform. So let's actually do input tensor.print first, so we don't really need to do anything else. So we'll just return let's just try this. All right. Okay, so TensorFlow JS still needs to load. All right, so we'll, instead of returning, we'll just comment out everything here. Cool. All right, what is this doing? Okay, so the input tensor does work. So we actually get a tensor with the right shape. Cannot read property 0 of undefined. That's from before, right? Maybe. Yeah, okay. Yeah, so now we need to see what's going on here. Why is this not being loaded properly? Load layers models. Let's take a look. Load layers model. Model summary. All right, so let's load the model and then print the model summary before we do anything else. Options. What options do we have? Options. Let's make this bigger. All right, so yes, so the model seems to be okay. Load graph model. So I think we saved a Keras model, so it should be layers model, right? Load model consists of layer objects, includes topology and optionally weights. See the tutorial name How to import a Keras model for usage examples. How to import a Keras model. So maybe that's what we need to look at. Tensorflow converter, we have the converter, load layers models, example from pixels, from pixels. Now the model is ready for inference evaluation. Okay, so we are creating a uniforms model. All right, so we actually need, this might be a problem. So these are floats, but we need RGB values, right? Now I'm thinking, I don't know if we need floats, what type of inputs we're getting. All right, so let me take a quick look at, okay, let's just test that one. So random uniform. Well, let's first take a look here. Path array options. Strict on progress. Optional. R. Okay, let's take a look at the signature there. So this is all right. Let's take a look at the model.json file first to try to understand it and see if we can identify it. So output. Right, so the first thing, I think this model is being loaded properly. So I don't understand what's going on, but load graph model, just to test what happens there. Type graph model. Graph model. Let's just test this to see if it fails. So right now, this is okay. So summary does not exist on type graph model. Right. Let's test. All right. So that doesn't solve anything. So load layers model. And what we're gonna do here is that instead of this input tensor, we're gonna create a set of zeros, which is gonna be TF zeros with the same shape. And let's try again. Loading the model. All right, non-trainable params, total params. All right, so I loaded the model, but I didn't print this thing. So we're gonna predict, and we're gonna print the prediction. You know, if you have any questions on the way or any comments, feel free to drop them on the chat. All right. All right, we're still getting nuns. Why is this? Okay. Okay, so let's see, convert pix-to-pix model to Tensorflow JS. So Jining actually has done a lot of work with pix-to-pix, and I will recommend you take a look at her projects. And also it's like a huge contributor to the ML5 library that we've also seen. All right, so let's see, this repos moved to JS Lite. All right, see live demo here. So let's just make sure that it's not about the model, because if it's about the model, maybe we have an easy solution. So where is the model here? Picked. So what's the format of this model? Picked. So this is the old code to run these models in JavaScript, but I haven't been able to run the new ones in JavaScript yet. So let's see how this works. Let's see. All right. Okay, so let's take a look. So this was a Keras model. So we have here live 28. We have this Keras model, and hello Sajay. So can you hear as well? Can you see as well? Nice to see you around. And all right, so the input, so this is Keras 2.4.0 tulips live. So this is a model that should work to predict, right? And right, so we're gonna try to use a pre-trained model here, and we're gonna have to end early today because I don't have that much time. Okay, so yeah, thanks Ajay. So we have the model here which we downloading, and we put that. Right, does this exist? Cool, so we have that input, and where is our model? All right, so let me go back to my drive. So this is right. So we're gonna try, well, let's try with this one just to see if this works. So I'm gonna have to authenticate, mount my Google Drive. So let's make sure that we have a GPU. right. Copying the token behind the scenes. Okay. All right, so let's reactivate the screen there. Cool. So now I'm trying to get to the right path. So I don't know why that doesn't exist, but this is gonna be here. And so here we have collab, so content. Let's see how they change this. So now they put this is G drive. All right. So we should be able to list. All right, so we can list. And we can see our models there. Okay, and we just need to do this. So we're loading the model and we'll print a summary, which should yield the same thing that we were seeing inside of JavaScript. Yep. Seems the same model. So we're gonna load PNG flower. All right. Let's put here input and that's it. So we have an input. So we're gonna render the import mat plotlim. I disabled a power level. I don't know what that is. Code completions. Port mat pipeline SPLT. I never remember this. All right. So we got that, and now we can preview our image with MATLAB Plotlib. We expand the dimensions of the image, and we can print. So let's print the input image here. So print input image. Right, once. All right, so this is working. So we're predicting now. It doesn't seem like this is doing anything special to run the prediction, really. right, so we got the prediction there. Float 32. And yeah, so that's our prediction. So this is not a great prediction, but it works. Okay. All right, so this works. Read file, decode, convert image D type. All right, so let's actually try to do what we were going to do instead of testing with something that doesn't make sense. So I'm going to leave this here, and we're going to go to here and to this code that I had. So we're gonna read a file, so from disk. So let's say we just do this one. So is this an image? Open. All right. So we have this image here, which we can open. Okay, so that image, for instance, but I guess we can just get the sample that we have here and download it. Wow, what is this? All right, so that was weird. Okay, so we have our input image here. We've used it in other live streams, and now what we want to do is load that into TensorFlow with TensorFlow JS. So we are going to load this, read file sync. So TensorFlow JS read file fs image pixels. Let's see. All right, so here decode, return pixels, read image. So here we have image byte array, image number of channels, image byte array. Read image. Image to input. Do we need to load our model? We already load the model. So all right, so we read the image. So we have this function here. We're gonna read the image and JPEG. Well, to simplify things right now, let's Okay, we're gonna use JPEG.js. And I will just convert the image. So I'm gonna go and convert with Mogrify to JPEG. So everything is PNG here. So now we have the image both in JPEG and PNG. Right, great. So that way we can use this code directly. So fs, I'm gonna, I don't usually copy paste, but that way we're gonna be faster today. Huh, why is this doing this? Okay, let me just quickly try this. Does this change anything at all? Cannot find model. Oh, okay, so we've moved. Right, let's see if the model loads first. So we're trying to load the Tensorflow Js model. Seems like it does load it. It seems like this is working exactly on the same way of what I had before. So that code doesn't seem to change anything. All right, so we're gonna revert back to what we had. Okay, so now we can go to what we wanted to do, which is get these two things there. Right, so we have this function here. So we have the read image function, and we need the image byte array. Yeah, so okay, let's get these helper ones. So we have, this is JavaScript and I'm doing TypeScript, so I have to type the things for the compiler not to complain. So you can see these complaints about the type of this variable. All right, so let's just try that to read an image. So we have a path, so we read an image from path, which is going to be simply flower or input, just input.jpg. And we're going to load that image here. So we load it here, input, and the path is image path, and we put this input. Right, let's see what happens there. So at least we would, we would have to get, okay, cannot find model JPEG.js. Right, so in the other folder that I opened, I created a Node.js project, right? Yeah. All right, so yeah, I installed the JPEG-S library in a different directory. Cool, all right, so I don't think this is gonna work. I don't really think this is gonna work yet. Super message. Expected input to have a good shape. All right, yeah, so we need to make this a batch. So input, I can make this work this way, right? And while we execute, we can take a look at how to do the expand dems. Okay, expand dems. Input batch. Input expand dems. Access. I don't really know what access it is, but let's take a look at this one. And the access here is 0. All right, so maybe that's not it. We'll change it to 0. And our prediction, right? Okay, let's try now. All right, let's see. So this is almost there. Okay, so this is still failing. Okay, I'm gonna take a really quick break, and we'll keep trying in a second, right? All right, so I'm back. Cool. What do we have here? Yeah, so I'm not fully understanding what's going on. So this is just something with the model not being loading properly, but it seems like we're providing the model with the right input image, right? So this is so we're going to take a look here. If we were to say input batch print, right? We just want to load our image, so we're not even going to load the model now. We're going to load TensorFlow. We're going to create a batch as if that was our input batch, and we're going to return here, which is going to print the input tensor, and it should be a representation in floats. Oh, okay, so that's good, because it's not good. That means that the format is not the right one, so it's good that I realized that because we need to do these things. We decoded the JPEG. We need to convert the image D type. Okay. All right, so let me make sure there's no lag. Okay, so maybe, maybe I can. So we have here the image D type, resize. Okay, what's the input size of this? This is 256 already. We're reading the file, so we just need to convert to float. Float 32. Not sure we can do that. TFMol. Let's try this one. All right, so I'm trying to, divide. So I'm trying to divide the, so the input tensor, so the image we loaded, and we divide it. Okay, so it seems like this might be working, but what happens if we edit this image in Photoshop and we put a different color? So right now we have 111 that represents color white, but I'm not sure about the type of this tensor. So values, let's see, Tensorflow Js, convert tensor to float 32. Right, tfcast. And we can put this operation in different lines. We don't need to have it in just one. But okay, so I don't know if that was happening already or it's just that JavaScript rounds it. I'm gonna fill this all with a color, so let's make it red. How's the speed of the video and the audio right now? I feel a bit of lag on my end. And we're gonna close a few things. Okay, should be good to close some of these things. And Visual Studio Code again. Okay, so let's see. So this is taking longer than I thought, but you know, this way we can get used to a few things with. Oh, okay, so this is saved there. Input red is going to be the name. All right, so input red is the color. All right, so we get the right format now. And this is just the input image. I'm not sure about the output image. So we have that input batch as df tensor, and then we do print. And I think this is what we should be getting. Okay, we're not loading the model. So now we're loading Tensorflow Js Node.js, loading Tensorflow Js model. We are outputting and we're getting none again. Why are we getting that? And what is the undefined? Print output. So we print the prediction, input batch. Pick this URL, got one. Model.predict. Okay, so 1 second. Input batch. Okay, let's see. Right, so this is one of those roadblocks that hopefully will turn out to be something silly, but something I haven't figured out yet. So this is, we're trying to convert a model to TensorFlow JS, and we're getting two undefined tensors. Oh, okay, so we don't need to print if we are if we're calling the print method. That's why we're getting an undefined. All right, so this is a roadblock, and I'm not sure what we're doing wrong. So here we have a load layers model, and we load the model. We have all the shards there. This model is model.json. We opened it here. What is the input? So Keras 2.4. TensorFlow converter, no float. Let me see if there's something there. All right, so I'm gonna take a look quickly at how to load a model from like a Keras model. So when we load the model here, do we do anything special? TF model load model path. Compile it manually. So is the shape the same? Let's take a look at this. So this is a model file. It's model summary. We're gonna go to the desktop. So this is type 29. And we're gonna create a file that is gonna be TensorFlow core txt and TensorFlow Js txt. TensorFlow Js is gonna contain the print information from here. Right. And then we're gonna compare it with Visual Studio Code. So we can go here, we can click on this file and that one. So click, and then compare selected. And we're gonna go to this code file, remove this part. Input layer. It's exactly the same model. Data sync, right? Okay, so we are going to go to, okay, so I'm gonna go back to, not this one, I'm gonna go back to the initial code and take a look at what we had there. So we had array sync, and our array sync code I think returns the same that this print method, and I don't think we can do this. Well, let's try it. Maybe data sync. Maybe that's all. None. Why are we getting none? I cannot see anything done differently here. So we get the summary, read the file, we decode the PNG, we convert the D type, so we resize to 256, which we already have, and we expand dimensions, we predict with training true. All right, this is what predict Tensorflow Js training true. Well, if we solve it, I'll be really happy, even if I spend here 1 hour. Predict, let's see, predict, config. Right, so first let's do this, predict, and put here verb post true. Okay. predict input batch. Input. No, this is a tensor, it's not a batch. All right, so let's see. I don't really know how we're gonna solve this. I don't think we have an easy solution right now, but the thing that I spotted here is that I was getting a similar error on the cloud when I was using this model with TensorFlow Core when training wasn't equal to true when we were predicting. But this option doesn't seem to be available on the cloud, so on TensorFlow JS, and that worries me because I don't really know then in what way I should do that. Okay, so we're getting a none, and this doesn't work, data sync. Data sync. Synchronize all of the value of these blocks, the UI thread until the other can cause performance issues. Array sync. Returns the tensor. Okay, so both of these do a similar thing, and they're both failing. And can we just do this? Print probably. No. Okay. So, what other methods we have here? So we have feed on dataset, feed, compile, optimizer, compile. Let's see, compile, loss, optimizer. All right, so we have here, so last thing we'll try, and otherwise we'll go and we'll continue. I'll try to solve this offline. So model training. Let's see what optimizer we were using, so in case that we can compile the model. Let's see, so if we okay, so all right, this is exactly my problem. Right, so the coding question looks like this. Training true. Oh, all right. Let's take a screenshot of this and save it. All right. So my screenshot is here. Model.apply. All right, if this works, so this is, hey, Jose Luis, how's it going? Man, I've been going down the rabbit hole for an hour, and I think this guy just solved my question or my blocker. So this might unblock me. What are you up to? How's it going? All right, let's try it. Let's see if this actually works. It's gonna be really exciting. So output model apply. All right, let's not copy. Let's just type it to make sure we understand. All right, so hi, Jose Luis. Yeah, I don't know if Jose Luis is hearing us, but I just texted there. All right, so the apply method. Let's take a look at the documentation here. Yeah, that's like my bread and butter. Okay, so preparing lectures for tomorrow. Awesome. Apply builds or execute layers logic when called, blah blah blah. All right, so let's try this method then. So we have this dot apply. Great, so constant output. Cool. All right, so we will hide this thing here. So we have our model here and we can print our summary. And what we're gonna do is model apply input training equals true. And I believe we don't really need to put this thing here, right? And we have our input, so model apply. And that's our prediction. All right, so we apply the input. We don't really call predict. All right, so dot data. And this prediction is going to be as, so we'll do await as tf.tensor. All right, I can see you're hearing. All right, so prediction print. Yeah, let's just test this out. I don't know if this is gonna work. Hopefully it does. And if it works, we'll recap on what we've done. All right, fingers crossed. So this is exciting. I'm not super sure this is gonna work, but hopefully we found it. Okay, error. Incompatible with layer, expected dim. All right, so one more thing. I think I made a mistake. So we have to put the input batch, not the, all right, one more test. All right. So that's loading TensorFlow, our model, predicting. Oh, nice. Okay, so this solves it in some way. This does solve it. So we need to. Okay, so this is, I don't really have any like party sound or anything, but this is finally good. Okay, so hopefully when we edit this video, it'll be a lot faster. So I'm going to recap on that part, and I'll be mentioning this. All right, so okay, let's delete this and this. All right, so kind of going back to how this works or not. So I'm gonna put the issue link on the Discord chat. So here, okay, and I'm gonna go to my tab here. Okay, so this first thing, and this is awesome. Okay, so we're gonna keep this here. I'm not sure if this works completely yet. Okay, so we close our tabs, and as a recap to the video, so here in the TensorFlow core version, we were predicting with our input image. So this is a batch of input images formatted in the right way, and we have our training flag set to true. This tells the model to predict with the weights that we're trained with, right? So it's the knowledge that the model has after training. And the problem we were having is we didn't really know how to specify that flag with TensorFlow JS. And we were running this code and it was returning none all the time, not a number. So what we have to do here is to call the model.apply function with our input batch and set the training flag to true. Then we cast this prediction result to a TF tensor, and then we call prediction print. And that seems like it's working perfectly. So I'm going to predict once more to verify this with our input image. So that's this flower that we have here on the desktop. Let me show it here. So we're predicting with this image. And yeah, thanks Jose Luis for passing by. I'll see you soon. Thank you. Yeah, we have to catch up. All right, so all right, cool. So we are getting some output and it's a tensor. So now we just need to wrap it up and save that image as a file. So image, so we'll put save path, and we're gonna put here users desktop output dot, let's say JPEG. Hopefully we can do that. And we have our prediction, so we can print it. We're gonna remove this, so we're gonna remove this, and we print our prediction, and that works. And we're gonna save our file here, right? So we're gonna save it next to our input. So we have our input here, and we're gonna save our output there. So we're gonna make this all right, to clean up, can we clean this up a bit? Maybe not. All right. Okay, whatever. We'll just take a look at there. So we have our input here, which you cannot see because it's me there. Okay, so we have this. We don't need to create a fake input tensor. So this is actually just load image from file into a tensor. and then we predict, and then we want to save prediction output. All right, so in our prediction, we actually have the item 0, and I'm not sure if we're going to be able to do that. And hello, Jean-Marc. It's been a long time since I've seen you, but I'm really glad that you got time to connect with us and see you again. So hello. We're taking a look at Tensorflow JS, so we're taking a look at how to load a model that we converted from pics to pics into a Tensorflow JS, and we're trying to make predictions. If we get to do this, we'll be able to load this model on any web tab, an Electron app, or in Node.js in the backend to make predictions with this model. So we've made a prediction here, so print of undefined. All right, so we can't do that. We can print the tensor, but we could get the data, so we could do array sync now, I guess, and then we could do constant data. Well, can we just get the data sync and then log data? All right, I don't know if this works. Let's try it out. All right, so let's go to Google now, so we can close this because it works. And well, let's actually leave it open, and we want to save Tensorflow JS prediction to JPEG. TF node. Right, encode JPEG. So image format encodes an image tensor to JPEG. So all right, so we have some minuses here, which I'm not sure what we'll do with them, but we're going to try to map these tensors. So we're going to let image be our data. Can we get data? Can we get the first of the data? Hard to come around and get the kids to bed at the same time. Always a pleasure to listen and watch you tinkering. Yeah, awesome. I'm glad. I'm glad that you do. I really enjoy having you guys online live. Can already get about so okay. So image out. Let's just. I don't have my mind for good variable names now. All right. So we have the image out, and what I want to get is to say tf multiply so image out, and yeah, I don't know if I can. Right, let's try to find an example that actually does this. Without the canvas. Tensorflow JS node save JPEG tensor encode JPEG maybe. Okay, so that example that we had probably had the file. TF node encode stylized transform net predict squeeze. Squeeze. Okay, so maybe we use squeeze. Predict. So squeeze and in Node.js. New image. TF node. So we have here our data. Right, so we'll leave this here. So we can do here prediction.squeeze. Let's try it out. And leave that there. Image, so save path. All right. While that runs. All right, so let's see if this actually gets solved. This is, we have an image there and we have a black output. Okay, so this is what we were seeing online. The good thing is that we're saving that image, and what I believe we have to do is multiply by 255, and maybe Tensorflow Js will do the rest. Okay, so who thinks this is gonna work? All right, so we have this black output here, and we're gonna wrap up if we do this, because this was our goal of today. So read an image from this, convert to a tensor, feed the image to the model predict function, and save to disk. And you know, we had to do some extra stuff, but we couldn't. Okay, so that's that. So it's float, and we need to cast it. Cast, and okay, this doesn't really matter because we're doing that below there. So output x prediction, squeeze, multiply by this, and we're gonna cast int 8 maybe, I don't know. So we do tf cast. Int 32, right? Once more, not leaving until this works. All right, and as always, you can like this video if you wanna support the channel and the work that I do here. It really helps for other people to discover the channel, the videos, and the project. All right, so is this there? Not yet. Okay. So what are we doing? So I have, all right, again, I'm not saving the right variable, so we haven't tested anything yet. All right, output can be there, so tf argument of type tensor rank is not assignable to tensor 3D. Maybe squeeze. I don't know what squeeze is gonna do here, but let's just test. Trial and error. That's what I'm going for today. A lot of trial and error, but hopefully we get there. Okay, data of undefined body call already, blah blah blah. All right, so maybe let's try not to do squeeze here. I don't really know. Tensor rank is not assignable to tensor 3D. Let's see here. Squeeze, maybe just a squeeze here. Oh, wow. Okay. I don't know what this is. 255. Well, I mean, it's working in some way. Not properly, but it's working, it seems. Well, okay, so it seems that we're going out of range, but so this is really nice. The output I think should be something like that. And we're getting partially something that looks like that. It just seems like we have, so this operation is not being properly done. Why? What's going on here? So prediction. All right, so maybe I don't need to make anything like this. Int 32 output. I don't know what this is doing. Okay, let's try with that. I think we already tried this, right? What is that code sample doing? So predict bottleneck. Oops. Okay. Right, console log data. So we have this image here. Let's see. So Tensorflow JS prediction remap JPEG. Custom object, image classification, predict. Save Tensorflow JS node prediction. Right. How, okay, so let's take a look at TensorFlow JS API. So we have some values that are outside of the scope. So map, maybe, do we have a map method? Dataset, no. TF tensor, where are you? All right, so we okay, node API with the latest, right? So that would be 3.6. JPEG, encode JPEG, encode PNG. 3D uint8 tensor shape height with channels. So int32, why can't we? Okay, uint. Right, so where is the Tensorflow Js API? So API reference, non-API, TensorFlow visualization, React Native. All right, so we have here tfcast. tfcast transformations int32. So why? All right. All right, so the last thing I can think of is that we're going to, so we have values between -1 and 1, right? We would have to add 0.5, so multiply by, so x by 0.5 and then plus 0.5. So we have to multiply by 0.5, well, the output, so let's leave this out. So multiply by 0.5, add 0.5, and then multiply by 255. Right, so let's try that. That's like a manual remapping of what I wanted to do, and if that doesn't work, I don't know what to do. Right, so that's saved. All right, we got something here. Great. I'm not sure this is what we're getting here, but it might be a different model version. But this looks good to me. I mean, let's let's draw a new input. So a new input for this model. Let's maybe let's just copy that and edit this one. Okay, so we have this output. And we're gonna draw, this is a tulips model, so we're gonna draw a tulip. So we do that. Let's try to copy the width, which is more or less here, 4, 3. All right, so tulips could be something like this. Right, we save under the same file name, we run this, and we have here our output image from before. We have our input, and what are we getting? So loading the model, and there you go. All right, I mean, it seems like it works. We could verify with other models, but yeah, I think this is working. So let me see what model we were using here. Let's save everything in folder 29, and let's go to 28. What do we have here? Edges to tulips live df 2.4.0, and in here we were loading, maybe that's displaying it wrong and we're mapping it right. Model, yeah, same model. So maybe is this one that's mapping the things wrong and not us. That could be really cool. All right, so next live stream, I want to enjoy having this all finished and working and done, because today has been a success, even though we almost killed it. So we're going to make a tutorial on record tutorials on, and then we got here how to convert pics to pics, TensorFlow core models to TensorFlow JS. This is using TensorFlow JS convert. Next thing, predict. So generate images using our custom model in Node.js. In Node.js, and then a new could be that we're going to use pics to pics models. So generate pics to pics images on our website. All right, so that's it. We got it. And I think, this is enough for today, and I'm glad that we managed to do it. All right. So this is from -1 to 1 into 0 to 155. Okay, great. Thanks for being there. Any links that I have to put here, Have you tried pix-to-pix model for portraits? Yes, I tried it a while ago. It didn't work great. I think because you said it right before we were wrapping up, I can show you. I think I have those tests here. So I did a few tests, and I think we have some outputs here. Maybe I don't have them here, but hopefully we do. Portrait. No, I don't have them here. But yeah, we did some tests. The things that we can do with portraits. So let me put this here. The things that I can do with portraits that we've done with portraits, and concentrated trying to look for this, is this ones, right? Okay. Oh. All right, let me load this file really quickly. So, yeah, let me load this file. Maybe, okay, let me load something here. Okay, 1 second. I'm just loading a presentation. Okay, so one thing I just realized is that I deleted the I deleted the other output, which I would have liked to keep. Right, so I know you cannot see my screen, but it'll be up soon. Right, yeah, so this is a test that I've done with StyleGun. So this is not pix-to-pix, but StyleGun. And this is a latent space walk. We've shown this in other live streams. And this is the training set, the data set that was used for that. So it's 10 portraits, then the data set was augmented, and we actually trained, and I generated an interpolation using, I mean, you can see this, that, and that image mainly, and I think this one. Yeah, so that's what I wanted to show. So check the thumbnails. So let's quickly do our homework. I like to do this that way I don't have to think about it later. We've covered Tensorflow Js and pix-to-pix, which is good enough. All right, so pix-to-pix and that, and I'm doing this thing where I put this at 60% if I didn't do it. So I'll export this image so to JPEG and done, and we're gonna clear recent, close, and you know, now that it's open, the one thing that I want to make sure I do is I save also the other output. So this is like 29, so that would be with this input here, input, and we run once again our Node.js. So our okay, so that there, this is running, and this is predicting, and better or worse, that's there. So B output, so this is B input, and this is A input and A output. All right, so this is something we've done today. We've seen these models many other times, but it's good, and I'll save this, which saved my day. And now we have to change that cover image, which is here. So we will put this cover image instead. That's part of our reminders or homework. Put that there, save, and we're going to schedule the new stream. So schedule next week's stream. I think I don't have anything there that makes me postpone it. I'm gonna randomly choose a color now. So that's gonna be what is it? 1, 2, 3, 4, 5, 6, right? So May 6th, 5:30. So this is how I'm doing this lately. So I have the topics here, and I put this there. So I choose a color. It can be a random color. I put these things as not done. So we just export this image again to JPEG or PNG. So we have that there. This is something we're going to upload to the new video. So when I create the stream, so I go and schedule the stream, reuse the settings from the previous stream. I make it so it doesn't announce that it's gonna happen yet. I put it private, so I put it at 7 p.m. my time, that's 1 p.m. EST. We changed the thumbnail. You have to wait for that to save, but we'll wait. It's not public, it's private. And this is gonna be live 30. We create there. That should be created. So now this one here, so this live stream. Yeah, John Mark, nice to see you around, and we'll connect soon. Hopefully you can make some room over the next couple of weeks. All right, and again, so schedule next live stream. So we've done that. We've put this there. So we're going to now clone this folder. So this is, we just require, so we clone the folder. This is today's date, and we have like 30 in there. So we do this. I'm gonna open this presentation, and what we do, one last thing, so I'm trying to get to a workflow where this is super fast and I don't have to spend that much extra time in preparing. Nice to see you. It makes me happy to see familiar faces. All right, so edit the master slide. We go here, we put this there. Oh, not there. I put this outside, so I get this color. I can get any color now, and I'm done. And now all the slides update. I can replace this image with the latest live that is done here. So this is there. It's today. This is 29. And another thing that we have to do manually is, I put this here, there. I have to put these items here, which are the same ones. No, not the same ones. Are the same ones than last week. I'm going to open this. I'm going to temporarily remove this. Invert, group, and copy that. So now we copy, paste it here. We can put it there. All right, so more or less that works. These are the new topics, and everything seems to be set for next week. So we have that, we have this, and we're gonna put here pics to pics. We wanna do like convert pics to pics models to Tensorflow Js. Convert. And the other one was generate pix-to-pix images in Tensorflow JS. And the other one was generate pix-to-pix images on a website. Vale. Right, and the other one would be the same. Generate pix-to-pix images with TensorFlow on our website. On the web. All right. With TensorFlow. Yes. All right. So that we remove this one, and that's that. So we have slides. I'm gonna close this. We have scheduled it. We've done that. And yeah, one last thing that I usually do is we have the new live stream code. So we copy the URL and then I'll make a short URL. So that's going to be live 30 and now live. So if we go to, let me see. So if I go here to Nono.MA live 30, I get to live 30, which is private and you cannot see, but it's there. It seems all right. So that is all, I think. Oh, okay. So last thing for housekeeping. So we have this code here. So this inside of live 0029. So we've created this. Let's take a look at what's there because I think I need to git ignore many things. So the slides are there. So this is live 29. We're gonna place this here, remove that and put that to the side. And lastly, so we have this thing. I think there are many things. Right, let me see. So cat git ignore. All right, so that doesn't exist. So we're gonna copy from 0028 tfjs git ignore to this directory. So cat git ignore, we have that. Git add this directory. Git status, right? And we're gonna do git commit 29. Add pix-to-pix Tensorflow JS predict version 2. And we push. And then we push. Okay, great. So open github.com/nono is been live, and we're lastly going to paste this project in here. So all right, so that's there, and I think that's all for today. So we can close these things. I don't think we need to save this. We had our model running, so this is done. So I'm gonna close this. I'm gonna close this. I'm gonna save and close this. I'm gonna close. I'm gonna close. And I think that's it. Right, we have this input here, which we don't need. We have this thing here, and let's do some housekeeping. Everything's good, and we're gonna go here. All right. So I hope you like this video today. So it's been challenging. We've gone through a roadblock, but I think we've learned something. And once again, if you've been watching, you probably heard me say before, liking this video supports the channel and the work that I'm doing here. And you can subscribe by clicking on subscribe and then clicking on that bell to be notified when I go live next or when I upload new videos. You are the main reason why I'm doing this. So I will really be willing to hear comments, suggestions, questions, or whatever you want to send my way. Join us on the community. You can reach out to me there at Nono.MA/Discord. You'll be redirected to an invite to join our Discord server. And yeah, without further ado or whatever, thanks so much for watching, and I'll see you next time. Bye.